Alright, today's video is going to be our first video of Chapter 5, and we're going to start with 5.1, Graphing Quadratic Functions. We're going to go a lot from our note sheet to our sketchpad, so make sure that when we're on the sketchpad demo, you're still taking notes on your note sheet. Alright, we're going to start by looking at the graph of y equals x squared. So let's switch over, and you see that we've got y equals x squared right here. I have it listed as f of x is equal to x squared, but we know from previous chapters that f of x and y both mean the same thing. So when we look at the graph of y equals x squared, we see that it's not a straight line, so it's not linear. It actually has this curved shape, and the name of this curved shape is a parabola. Okay, so this type of graph is called a parabola. There are several vocab words that are going to be associated with parabolas that are different than just a linear equation. The first is the vertex. The vertex of the graph is the pinnacle point where you change direction. So if I look at my parabola here, it's going down, 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 down. It hits my pinnacle point where it changes direction and it comes up. So my vertex would be located down here. So the vertex is going to be the lowest point of the parabola. In the example we just saw, when it opens up. And we saw that that was the lowest point where it changed from decreasing to increasing. And if our parabola is going to open down, it's going to be the highest point. Highest point of the parabola when it opens down. Either way, it's the pinnacle point where the graph changes direction. The axis of symmetry is connected to the vertex. The axis of symmetry is a line that cuts the parabola in half. So it's going to be that line that goes straight down the middle, so that if I fold the other half over it, it's going to be symmetrical. And we get the axis of symmetry is the line passing through the vertex. The vertex is the point where it changes direction, so that's the point that it's going to go through in order to cut it in half. Alright, so the next couple of vocab words that we have not talked about before is the orientation and shape. And actually, I take that back. We have talked about this when we've talked about absolute value graphs. The orientation is the way that it opens. Does it open up or open down? And the shape is the same as our absolute value graphs. You can either have narrow, normal, or wide. And all of the rules that we talked about before for absolute value bars are still going to hold true here. So opening up and down is going to be determined by the A value. Positive opens up, negative opens down. If it's narrow, the value is greater than 1. If it's normal, it's 1. And if it's wide, it's a fraction between 0 and 1. And all of those, we're talking about the absolute value of it. Alright, so we want to compare y equals x squared and y equals 2x squared. So this is where we go back to our graphs. We have y equals x squared already up there. So now we're going to compare y equals x squared and y equals 2x squared. So you can see that multiplying by the 2 has made our graph more narrow. And that's because when I multiply by 2, I'm growing at a faster rate. The faster I go up, the more narrow my graph is going to be. So the second part of that note sheet says what happens when we compare it to 10x squared. So we have that this is narrow, which you should have on your note sheet. And when I put 10x squared, it's even more narrow. So the larger your A value is, the larger the number that you're multiplying by is, the faster it's going to grow. The faster it's going to grow, the more narrow the graph is going to become. Okay? So in summary, on your note sheet it says summary, as our positive absolute value of A gets larger, the graph is going to get even more narrow. Okay, so we're going to move on to our second comparison. On your note sheet it says y equals x squared, and we're going to compare that to y equals 0.5x squared. Even though it's 0.5, it's not a fraction, which we dealt with a lot in the last chapter, we know that 0.5 is the same thing as 1/2. So we're going to compare just our y equals x squared and our graph of 1/2 x squared, or 0.5x squared. Since our a value is between 0 and 1, it's a slower rate than 1. The slower the rate, the wider our graph is going to be. So on your note sheet you should have that comparing it, it's going to be wider, and then it asks what happens when we compare it to 0.2. So you have to ask yourself, is 0.2 larger or smaller than 0.5? And we know that 0.2 is a smaller fraction. This is 1/2, this is 1/5. So since it's a slower rate, hopefully you guessed correctly that our graph is going to be even wider. Okay, so the smaller the fraction gets, in summary on your sheet, the wider the graph is going to be. And just so we haven't forgotten, we've got to make sure that we're paying attention to the fact that our values are between 0 and 1. Just because it's a fraction doesn't mean it's going to be wider. I could have a fraction of 4/3, but 4/3 is actually greater than 1, so that would not work. So be very, very careful when you are making those comparisons. Alright, so we've looked at a bunch of positive graphs on the screen. What do you think the negative graphs are going to look like? So let's go ahead and look at those. We've got our original graph of x squared, and if we compare it to a negative x squared, just like what happened with the absolute value bar graphs, it's going to create, or it's going to make our parabola, instead of opening up, it's now going to open down because it's reflecting over the x-axis. And let's compare that to, our note sheet says a negative 0.2x squared. Okay, so when we look at the negative 0.2x squared, we see that it's opening down and we see that it's getting wide. Just like before, you've got two things to consider when you're comparing. You've got the negative sign, which is going to make it open down, and you've got the 0.2, which is going to make your graph wide. That's why when we refer to the a value, we always refer to the absolute value of it. The positive tells you the orientation, which way it's going to open, up or down, and then the number is going to tell you whether it's narrow, normal, or wide. So it doesn't matter if it's a negative 0.2 or a positive 0.2, it's still going to be wide. The positive negative tells you which way it's going to open. And we can see that if we've got a negative 2x squared, the negative 2, the negative part tells me it's going to go down. The 2 tells me it's going to be narrow. A negative 10x squared, negative tells me down, 10 means even more narrow. And if I think about the negative 0.5x squared, the negative means down, of course, the 0.5. Now when I compare 0.5 and 0.2, 0.5 is bigger than 0.2, but it's still less than 1, so I should expect to see that in between those two, which I do. Alright, so let's now flip over to the back side of our notes. We're going to look at a couple different forms of how to write parabolas. And what we're going to look at today is standard form and vertex form. You're used to standard form from Algebra 1, and you see where our a value is. Now our vertex form, y equals a parentheses x minus h quantity squared plus k. Hopefully you realize that this is the exact same equation from our absolute value, except for we have parentheses instead of absolute value bars. The a is still going to be the same. It's going to tell you the shape and the orientation. Your vertex is at hk, and remember, anytime you have grouping symbols, the vertex x coordinate is going to be the opposite of what you see. And then we have the axis of symmetry, which is nu. Remember, that's going to be the line cutting the parabola in half. And we see that since we have a parabola going up and down, that line cutting in half is going to be a vertical line, and that's why we have x equals h. Alright, so what I want you to do now is press pause and make sure that you have your calculator out. So go ahead and press pause now and go and get your calculator. Alright, so when we graph these parabolas, they're going to have several different parts to them. Let's look at number 1. We've got y equals 4 times the quantity x plus 5, quantity squared, minus 9. When we compare the two forms from above, we can see pretty obviously that this is going to be in vertex form. That just means that we can take the vertex out of the equation. So let's start with part A, describe the orientation. Well, when we're looking at the orientation, we've got to look at the A value, just like we do for this shape. So we make sure that we look at the A value for part A and B. And in this case, we see that our A value is equal to 4. Because our A is positive, our graph is going to open up. And because our A value is greater than 1, we should expect to find a narrow parabola. Alright, so now part C, find the coordinates of the vertex. Use the calculator if not in vertex form. But our equation is in vertex form. It's the opposite of the inside, so negative 5, exactly what we'll see on the outside. So in this case, our vertex is at a negative 5, negative 9. D, write the equation of the axis of symmetry. So that is going to be the line that's going to cut it in half, and we know that it's a vertical line, so we know that it's going to be x equals. And this is actually really easy if you can remember what it represents. It's a vertical line through the vertex. Vertical lines are x equals. Just take the x coordinate from the vertex. So in this case, x is equal to a negative 5. For E, we want the y-intercept. Well, if we want the y-intercept, we know that our x is going to be 0. If we want the x-intercept, we know that y is going to be equal to 0. You can go ahead and plug 0 in for x and solve, plug y in for 0 in for y and solve. I find it easier just to do it on the calculator all at once. So I've entered my equation into my calculator. When I hit graph, if I want to find the y-intercept, I want x to be equal to 0. So to do that, I do second trace, which brings us to our calculation screen. I want number 1, the value, and I want to find the value when x is 0. So I find that my y-intercept is at 0, 91, way off of our grid, which is totally fine. Now we want the x-intercepts. The easiest way to do this is go to your y equals and add in the equation of 0 into y2, because we want to find out where our parabola is going to cross our x-axis, and that's when our y is equal to 0. Alright, so now we want to go back to our calculation screen, and we want to find the intersection between the parabola and that horizontal line, or the horizontal line at 0. First curve, it'll always start in y1, enter. Second curve, enter. Alright, go back, we guess, and we see that our first intercept is at a negative 3.5, comma 0. Make sure that it's changing to the intersection. First curve, second curve. Now we've got to scroll over, we're going to get the same one. And we see that that's at negative 6.5, comma 0. Alright, we start our graph with our vertex at negative 5, negative 9. Our y-intercept is too high to reach, so we go on to our x-intercepts at a negative 3.5 and a negative 6.5. So we've got 3 points in our parabola. And we make sure that we've got a curved shape. That's a really bad curved shape. And then we've got our axis of symmetry, which is going to cut that parabola in half. Alright, we are running out of time, so we're going to do the second one quickly. We see that this one is going to be in standard form. Press pause and see if you can get the orientation and shape correct. Alright, because our A is negative 1, it's down and it has a normal shape. When we graph this, we see that it is going to be opening down, which means we are looking for the highest point. So go to second trace. We want the maximum. If it's the lowest point, we want the minimum. We go left of where the vertex is, then we scroll right of where the vertex is, and then we go back towards the middle where we guessed the vertex is, and we see that our vertex, that's going to round to 1, comma 2. Now the rest of it is a review from above, so press pause again and see if you can finish the rest of this one on your own. Alright, double check to make sure that the rest of your pieces are correct and that you have your graph labeled correctly. And you're done.